Hey everybody, welcome back to Lesson 5, Atoms with Charge. In this lesson, we are going to talk about factors that determine an atomic charge and then how to represent atomic charge using isotopic notation. So let's start by talking about what is an ion. An ion is an atom with either a negative or positive charge. Let's talk about how we can determine charge. So how's charge determined? Charge is determined only by the number of protons and electrons in an atom. And that makes sense because if you look at the bottom corner, protons and electrons are the only subatomic particles that actually have a charge. Neutrons are neutral, they don't have a charge. Based on this information about charges, if you're counting the number of protons and electrons in an atom, if you have more protons than you do electrons, your atom will be positively charged. On the other hand, if you have more electrons than protons, your atom will be negatively charged. Let's talk about how we can determine exact charge. Before we talk about determining exact charge, we're going to use a little analogy. Pretend that in a Bulldogs game, the black team is versing the gold team. In any game, at the end, there is a score. So in this case, the black scored 6 points and the gold team scored 5 points. So the game was 6-5. And usually, most people say that the black team wins by 5. And that's an okay thing to say. People say that all the time. Now let's use that analogy and talk about an atom. Pretend you're counting the number of protons in an atom and you're counting the number of electrons in the atom and you find that there are 6 protons there. And then for the electron team, there are 5 protons. So you can assume and say that the proton is winning by 1. Right? So because the protons are winning by 1, there is just an added point that you need to understand, that because the proton is winning by 1, the charge of the atom is actually positive 1. It's a positive because the protons are positively charged, and in this example, you have 1 more proton than you have electron. So you can make that assumption that this atom is going to have a positive 1 charge. In another example, what if the black team now scored 2 points at the end of the game and the gold team scored 6 points? You can say that the gold team wins the game by 4, right? Now looking at that in an atom's perspective, if you're counting or taking score of the protons and the electrons and you find that you have 2 protons and you have 6 electrons. You can also make the same assumption, but now the electrons are winning by 4. Using this information to calculate and determine exact charge, you can say because the electrons win by 4, this atom is going to have a negative charge because electrons are negatively charged, and that charge is going to be negative 4 because the electrons are winning by 4. They have 4 more electrons than you have protons. Let's take out the sports analogy in the black team versus gold analogy and actually look at an atom. So this is an atom of lithium. And if you count, we can determine the number of protons and electrons by just counting how many of each we have. And here we have 1, 2, and 3 protons. So we're going to take score and write 3 for protons. Now let's look at our electrons. We have 1, 2, 3, 4. So let's keep taking score. So now we have 4 protons. So from this, you can make an assumption that the electrons are winning by 1. So electrons win by 1 because at the end of taking score, the score ended up being 3-4 and electrons are winning. So using this information, you can actually determine that this atom of lithium has a negative 1 charge because it has 1 more electron than it does the number of protons. So this lithium atom will have a charge of negative 1. Using another example, now looking at nitrogen, this is an atom of nitrogen. So let's say we wanted to take score again. We're going to count the number of protons, and you can see that we have 1, 2, 3, 4, 5, 6, 7 protons now versus the electrons. Let's count the number of electrons. 2, 3, 4, 9, 10. All right, so now we have 10. And you can see, again, the electrons are winning. But how more are they winning? Like, how many more points do they have? And if you determine that, you can say that electrons win by 3. So we're going to write that. Win by 3. Right? Because they're winning by 3, the negative team is winning. So that ultimately determines that the final charge for this nitrogen atom is going to be negative 3. Because the electrons are negative and they're winning by 3 points. So this nitrogen atom will have a charge of negative 3. If we go back, it had... So the other part of our objective was to say, well, once you determine this exact charge, how do you represent it using isotopic notation? So everything is the same besides just 1 point. You have to put the charge in the upper right-hand corner next to the symbol. So we call that the charge box. So with our previous examples of nitrogen had a negative 3 charge. So the way that we would write this is we would write the symbol, nitrogen. We determined that the charge was negative 3. We would write the atomic number, which would be 7. And then we would write the atomic mass. In this case, it would be 14. So this is how you would write charge and represent it using isotopic notation. So let's do another example. So you understand that your A, Z, and X and your charge goes in this charge box in isotopic notation. So what happens if you have something that looks like this sodium atom and there's nothing written in the charge box up in the right corner? So what then you can assume is that there is no charge. Then those are considered neutral atoms. So this atom of sodium has no charge represented, right? Now let's basically take score and calculate and write the number of protons and the number of electrons found in this atom of sodium. So the easiest way to start is by looking at the atomic number, because the atomic number tells you how many protons are in that atom. And in that case, your number of protons is 11. Because there's no charge in the charge box in the upper right-hand corner, we can assume that the number of protons equals the number of electrons, because in a neutral stable atom, the number of protons are going to equal the number of electrons. Now let's look at this example here on the right side, where now for sodium again, let's just put an A right here because that is supposed to have an A next to it. All right, so now it's considered a sodium atom. For this sodium atom, we can see that in the upper right-hand corner, there's a positive 1 charge. So we have to account for that when we're taking score of the number of protons and the number of electrons. And you can see that it's a positive charge. So that means that the positive team, the protons, are winning by how many? They're winning by 1. So the number of protons is always going to be the number of atomic number at the bottom. So that is 11. So we're going to write that down. We're going to write 11 for protons. Right? Now looking at the number of electrons. Because it has a charge, we cannot assume that the number of protons and the number of electrons are going to be the same. It has a positive 1 charge. So because of that, the positive team is winning by 1. The number of electrons now become 10. Right? It's 10 because now you can say that the protons win by 1. If you're looking at the 2 different scoreboards right over here. And that would be a correct assumption to make. So a quick recap of everything that we talked about in this video. We talked about the definition of an atom and how atoms are basically, and ions are basically atoms that have a positive or negative charge. We talked about if you have more protons than you do electrons, your atom will be positive. If you have more electrons than you have protons, your atom will be negative. And lastly, we talked about how when you do find out and determine the exact charge of an atom, you can represent that in isotopic notation by just putting the charge in the charge box in the upper right-hand corner. I hope this video helps, and when you're done, be sure to answer the on-course assessment questions and let me know if you have any questions. Thank you.